everyone, today we would like to introduce Telecommunication Laboratory 1 Part 8. This part involves sampling and reconstruction. We put the dual analog switch module in the immunotherms. This module is used for sampling. Okay, we connect the message signal to the input of the analog switch module. You probably know that this signal has a frequency of 2 kHz. Next, we use the sample curve that has the frequency of 8.5 kHz. This frequency is more than 2 times the frequency of the message. It is called a good sampling rate. The signal will be able reconstructed if we use this sampling. Okay, we connect the clock sample to the control 1 channel. After that, we display the message signal on the oscilloscope. This curve will indicate that every 1 second the power appears about 8,000 terms. We will know how to obtain the sampling. We show it on the oscilloscope. It is found that every time a message signal appears, it is sampled. This is the output of the sampling. Okay, we display it on the oscilloscope. We will see the signal as follows. Next, we move the signal a bit to easily observe. It is seen that it is sampled when the signal appears. This manner is called natural sampling. The range of signal that have voltage 0 volts is the non-sampling range. For the sampling range, the sampling signal will show the shape of the message signal. Yeah, finish experiment 1. Let's begin experiment 2. We will observe the spectrum of the sample signal. Therefore, we display the signal on the spectrogram. This is the sine wave that have a frequency of 2 kHz. If we observe it in the frequency domain, we will see the impulse at the frequency of 2 kHz. Therefore, we will show it on the sprite. Yeah, as we expect, the signal appears at the frequency of 2 kHz. Next, we observe the sample signal in the frequency domain. The original spectrum will be copied. It is found that the amplitude gradually decreases. Okay, and next experiment 3, we will reconstruct the signal. Okay, we put the low pass filter in the immunotherms. Then we connect the sample signal to the low pass filter. Next, the output of the low pass filter is shown on the oscilloscope. The message signal is also shown on the oscilloscope. We adjust the cut-off frequency. It is seen that we can reconstruct the signal, but it's maybe not perfect. For the next experiment, the signal cannot be reconstructed. Okay, experiment 4. We display the sample clock on the oscilloscope. It is observed that the blue wave have the frequency more than another one. Next, we put the audio oscillator in the immunotherms. Okay, we will generate the sine wave that have a frequency of 4 kHz. It is found that the frequency is about 600 Hz. Then we adjust the frequency to 4 kHz. We will compare 3 clock samples that are 8.5 kHz or oversampling 4 kHz and 2 kHz or undersampling. Okay, we show the TEL on the oscilloscope. It has the frequency same as the frequency of the signal that we generate. This setup generates a signal that have a frequency of 4 kHz. We can generate the clock signal from the audio oscillator. If we use this signal as the sample clock, the signal can be reconstructed. But if we use the sample clock that have a frequency of 4 kHz, the signal distorts. When we increase the frequency, the signal can be reconstructed. Theoretically, the signal can be reconstructed if we use a frequency of 4 kHz. Next, we connect the TEL signal that have a frequency of 100 kHz to the dual analog switch. After that, we will observe the signal in the frequency domain. We will use the TEL signal that have a frequency of 1 kHz. We show the TEL signal on the oscilloscope to adjust the frequency to 1 kHz. Then display the sample signal on the oscilloscope. Okay, we adjust the frequency to 1 kHz. This is the case of using the frequency of 8.3 kHz. Next, we change the frequency to 1 kHz. We will see the signals as follows. We press the Run on Stop button to observe the signal. Change the frequency to 8.3 kHz. After that, we will observe the signal in the frequency domain. We adjust the reference level. Change to 1 kHz. We will see the signal like this. We show the message signal on the sprite. We will see one impulse. After that, we show the sample signal on the sprite. Next, we set up the frequency to 1 kHz. Then we use this signal as the sample clock. Next, we show the sample signal in the frequency domain. We will see the signal as the figure. It is not the original signal. If we filter it with the frequency of 2 kHz, we obtain the before impulse that have a frequency less than 2 kHz. This is spectrum of the original message. It have not the frequency that is less than 2 kHz. If we sample with a suitable rate, the signal have no frequency that is less than 2 kHz. Therefore, we can recoup this signal by using low-pass filter. If we sample with an unsuitable rate, the signal at the frequency is less than 2 kHz appears. Although we set the cut-off frequency at 2 kHz, we obtain that impulse. That means we cannot reconstruct this signal. You can choose the frequency by yourself. Okay, finish.